Hi everyone! So as you can see, this printer differs quite a lot from the standard Prusa MK3 which you can buy from the Prusa. The first and most visible thing is the MMU module on the top of the printer, and when you look at it from the outside it looks a bit like the Bowden tube setup, which is used on some cheaper printers like Prusa Mini for example, but it's not true. The upper motors only feed the filament to this motor, which is the actual extruder motor, which feeds filament directly to the hot end and all the other parts of the printer. And this module is only responsible for selecting the given filament input and then feeding the selected filament into this motor so that it can pull further. And this allows for some pretty nice designs to be made, for example multicolor printing without gluing on painting by hand, and you can also use different materials on single print, which allows you, for example, to use soluble supports, which makes using supports possible for some designs where they cannot be pulled out mechanically and can only be dissolved with the solvent solution, which is really nice for some designs, as I said. And the second major upgrade that we did, which is a bit less visible, is the Pi module that can be seen on the side of the printer here, and it is also connected to this Full HD camera module that is printed on this multi-axis hinge that allows us to adjust the position and angle of the camera to our likings. And the main advantage of using Raspberry Pi is that it allows us to send prints to the printer remotely, which means that we don't have to use the SD cards no more, and we can use software that for scheduling and planning our prints and managing the prints between many of our printers, because we have dozens of printers in our print farm. And it also has some pretty neat features apart from just sending the 3D files. For example, when you're printing many parts on the bed and one of the prints gets detached from the bed or in any other way has a defect, you can disable the part of the print bed to not be used, and the printer will ignore the part that has failed and will only focus on printing all of the other parts that are okay, which means that you're not losing everything you've printed, only the one part that failed. The other nice thing is that we can use softwares that use the camera feed to analyze the way our print looks, and they can actually detect failures. They can detect the spaghetti appearing on the bed, and they can detect if the print has detached from the bed and is moving freely around the bed, which is really nice and makes it so that you don't need a human supervisor all of the time looking at what the printer is doing, and you can have the software doing it for you, which is really useful. To show you how the MMU actually works and what it is capable of, we'll show you the little ship, which is the standard Prusa test print for the MMU module. And as you can see, it turned out really nice. The eyes are black, most of the skin is purple, and the rest of the fur is white. And as I said, it allows for pretty creative designs to be manufactured using the MMU module. And about the camera, as I said, it can be used for automating some of the features of the printer and supervising the prints, but it also can be used for making a pretty nice looking time lapses. We use the Octo time-lapse plugin, which allows us to select many different presets for time lapses, and it is connected with the printer, which means that we can actually make a shot at the specific point of the print, meaning, for example, every layer, every half of the layer, or every layer, and with extruder positioned in a specific spot, which, as you can see in this video, it is set to be centered, meaning that the extruder is in the same spot every shot, which gives this really smooth visual effect of the print being like emerging out of the extruder. The other pretty nice thing about the Raspberry Pi ecosystem is that there are many cameras developed specifically for Raspberry Pi, which connect via this ribbon cable, as you can see. And the one that we have installed here is the Full HD, and it should be capable of making 2.5K photos and Full HD 60 FPS video. But unfortunately, we are still having some problems with it because just changing the resolution on the Raspberry Pi software side is not easy. It's rather complicated because you have to edit the config files themselves, which means pulling out the SD card and modifying the system files on a computer. But yeah, otherwise it works pretty well. It is really plug and play. This ribbon cables connects to a specific connector on the Raspberry Pi board, which is a dedicated port for the camera, and the first video we got worked pretty much right away. So that's really nice. And the other thing, which is more technical, as you can see, the Raspberry Pi is connected to the Prusa main board via USB cable, and it uses the serial protocol to communicate with the printer, and it allows us to basically tell printer anything. We can tell it to move, we can tell it to heat up, we can get the live information about the temperature, about the position, about the progress of a print, and it also gives us a pretty nice view, which we use the Pretty G-Code plugin on Octoprint to visualize the print without using the camera, meaning we get the live position of the extruder and the current layer and all of the other layers that already have been printed, which gives us a pretty nice visualization of the print.